Welcome to this video about tests about a difference in means. By the end of this video, you should be able to state appropriate hypotheses for a significance test about the difference between two means, and you should be able to determine whether the conditions are met for performing a test about the difference between two means. So remember, with the difference between two means, we're talking about two independent random samples. So in this scenario today was an article published online. It was in 2011, so it's been a while. But this article was saying that Americans may eat fewer calories at restaurants if the calories for the food items are labeled on the menu. So sometimes when you go to a restaurant, they'll say, here's your nachos, and they're 1,500 calories. So you know how many calories are in that whole plate of nachos before you eat them. So to investigate this, researchers compared Starbucks receipts from locations where the menus were labeled to receipts to stores where the menus were not labeled. A random sample of 30 receipts from stores with the menus labeled had an average number of calories of 225 calories with a standard deviation of 100 calories. A random sample of 40 receipts from stores without menus labeled showed an average of 265 calories per receipt with a standard deviation of 75 calories. Does this provide convincing evidence that the average calories per receipt at Starbucks with a labeled menu is less than that at a Starbucks without a labeled menu? So we have a lot of information going on here. So when I have a whole paragraph like this, I like to start pulling some stuff out. So I have two different samples. I have one sample that has a sample size of 30. It had a mean of 225 and a standard deviation of 100. And then my second sample size was 40. It had a mean of 265 and a standard deviation of 75. So you don't have to go back looking for everything when we do this. So we're looking for a difference in the average calories. So I am going to label these. So I'm going to state my parameter first, define it here. I'm going to say mu1 minus mu2. This is the true difference in mean in calorie intake. And I need to state the way I'm going to subtract these. So true difference in mean of calorie intake. And I'm going to say it's labeled menu minus unlabeled menu. Okay, so we had, and I did labeled minus unlabeled because they didn't tell us what direction to do it, but the labeled came first, so I often will just go in the order that they say them. So we have, that means we've got to take, to get our difference, we're going to take 225 minus 265 equals negative 40. So what that is showing that the labeled menu is having less than the unlabeled menu. All right, it doesn't talk about an alpha level, so we'll say we'll use an alpha of 0.05. And for our hypothesis, if we subtract them, remember your null means you're assuming there's no difference between them. So we assume there is no difference between them. And our alternative is suggesting when I subtract them, I'm going to get less than 0. Okay, so what I'm going to do is I'm going to have you finish the rest of this and come back and we will talk through it. So let's see what you can do on your own. All right, let's see how you did. So we've already gone through the state. For our plan, we have a 2-sample t-test for mu1, mu2. We have random samples, and I'm going to add the word in here, independent. independent random samples of 30 and 40 receipts. And then for our 10%, because we had a random sample, we have to check the, make sure we don't take too many. 30 is definitely less than 1/10 of all receipts, and 40 is less than 1/10 of all receipts for these two different stores. And then normal, we were able to meet CLT on both of those, so that's good. Now, for our due part, the mean, well, that's our null. We assume that there is no difference. The standard deviation, we worked out that I got 21.77. That's just the specific formula, plugged everything in, and I got negative 1.84. And you can look this up on Table B, where you get this range, or by calculator, anywhere between 0.036 and 0.038. So depending on which way you calculated it on the calculator. And then for our conclusion, assuming there is no difference in the number of calories eaten between the stores, there is a 0.038 probability of getting a difference of mean of negative 40 or greater purely by chance. Because 0.038 is less than 0.05, we reject the null. We do have convincing evidence that average calories at stores, so people eat less calories at stores that label menus versus those that don't. Because sometimes you're like, gosh, that sounds good. And then you see the calories, it's like, well, maybe it doesn't sound as good. So that's what our evidence is showing, that people do actually eat less, which supports what the Stanford Business article was saying. All right, let's turn this over and do a summary. So for our full significance test for difference of mean, as always, you got to find a t-score when you're talking about the different for means. And to get your statistic, you're going to take the difference in the statistics minus the mean, which in our AP stats world is pretty much always 0. That's your null. Divided by, you've got your standard sample standard deviation of the first one, and you'd square it, making it the variance divided by its sample size, plus the variance of the second sample divided by its sample size. Okay. Then we had our t-distribution with our degrees of freedom equals, take the lower number. For a difference of mean, that should be 0. And then wherever you mark, that's going to be your x bar 1 minus your x bar 2 in shade. And so there were a couple different ways to calculate this on the calculator. One is you go under those tests like before, and you can do a 2 sample t-test, 2 sample t-test, and say no to pooling. We're only going to pool when it comes to the proportion significance test. That's the only time, because this is one of our answer choices. The other one, I like the 2 sample t-interval t-test because it's very straightforward. The t-CDF in distributions is also one you can use. So they give slightly different answers, but either is fine. Or you can use just your Table B, whichever ones you're most comfortable with. Now I want you to try the check your understanding. All your statistics will come from here. You've got to run these separately. Run one variable statistics on each group to get your statistics that you're going to use for your 4-step process. Hopefully that was helpful. Let me know if you have any questions. I'll see you in class.